You've written V equals IR 1,000 times, but do you actually know why it's true, or did you just memorize it? By the end of this video, you'll never see a resistor the same way again. Think of an electrical circuit like a system of water pipes. Voltage is like water pressure, the push behind the flow. Current is the flow rate, how much water moves past a point per second. And resistance is like how narrow the pipe is. The harder it is for water to get through, the more resistance there is. But why does resistance actually happen inside a wire? Inside a conductor, electrons are drifting through under the push of an electric field. As they move, they collide with the atoms in the material's lattice structure, losing energy with every collision. Those collisions are what we experience as resistance. More collisions means more resistance, and that's exactly what the R in V equals IR represents. Let's put this into numbers. Say we have a 9-volt battery connected to a 3-ohm resistor. Using I equals V over R, that gives us 9 divided by 3, which is 3 amps of current. Now what happens if we double the resistance to 6 ohms? I equals 9 divided by 6, which is 1.5 amps. Double the resistance and the current is cut exactly in half. So Ohm's law isn't just a formula to memorize, it's pressure, flow, and friction all working together. Resistance comes from electrons colliding with the atomic lattice as they drift through a conductor, and when you double the resistance, you cut the current in half. Next time on Applicables of AB7, we'll break down 2 more core laws, Kirchhoff's voltage law and Kirchhoff's current law, using the same water pipe idea. Subscribe so you don't miss it.